In this video, we'll be looking at factoring monic quadratics. Now, monic quadratics are just quadratics, ax squared plus bx plus c, where the a value is exactly equal to 1. There's another video where I look at factoring non-monic quadratics as well. But for this video, we're just looking at the monics. Now, the way that I go about this is to work with the values b and c in my quadratic. And what I want to do is to essentially look for numbers which will multiply together to give the c value, but which will also add together to give the b value, keeping in mind that the signs may be plus or minus. So what I'm going to do to this example, I'll run it through with 4 different possibilities that we can get, and we'll see how the method slightly changes for the 4 different possibilities. The first example we'll look at is here, x squared plus 5x plus 4. Now note here that both the b value is positive and the c value is positive. So that's the first kind of monic quadratic we'll look at factoring. So as I was saying, what we like to do is look for numbers which multiply to give 4, which add to give 5. So I generally jump off to some working space and I set off a little column which says multiplies to give 4. And then next to it, I put adds to give 5. So these are just the numbers b and c slotted in there. So now I need to think, what are the factors of 4? Well, they are 1 and 4, 2 and 2, just going through it systematically from 1 and 2 and so on. And of course, that's as far as we'll get. Those are the only factor pairs that we can come up with. And what we do now is jump over here and look at the number we need to add up to. Now, because it's positive in front here, and so is our c value, we don't need to do anything with signs here. 4 times 1 is 4. 4 plus 1 is going to be equal to 5. So that's probably exactly what we want. I'll just check to make sure I haven't made an arithmetic error. 2 plus 2, that gives me 4. That doesn't add up to give 5, so that's not what I want. What I then do is take these two numbers and I use them to make up my factors in the factorized version of my quadratic. So I'm going to go x plus 1 and x plus 4. So you can see that the numbers 1 and 4 coming directly from our choices over here. As usual, you can always expand this out again to check that it does give you the quadratic you started with. And that's always a good idea when you're not very confident with these. The second example I'm going to look at is x squared plus 3x minus 4. Now, the numbers have changed, but that's not the big deal here. The issue is that we've now got a minus on our c value. So that's going to slightly change what we do when we come over to the side in our working space. We're still going to set up a little table, and we still want to look for numbers which multiply to give c, which in this case is minus 4, and which add to give b. So we want numbers which add to give 3. But it's what happens after we've found those factors that is changing a little from example 1. So ignoring the minus for a moment, if this was just 4, again we would have factor pairs of 1 and 4 and 2 and 2. But of course, in order to multiply these together and get a negative value as the result, one of them needs to be a negative, either minus 1 or minus 4. And in this case, it doesn't really matter because they're the same number. But the issue is, which one do we pick to be the negative? Now that comes about by looking at the sign of your b value. In this case, it's a positive 3. If we want to end up with a positive after we've added the two values together, we must choose the smaller number to be the negative. If we chose the bigger number to be the negative, then we'd end up with a negative sum. With the 2 and the 2, of course, it doesn't matter. Again, they're both the same number. So now we want to check things. We want to see what is the sum of minus 1 and 4. And fortunately, that adds up to 3, which is exactly what we want. So we'll tick that one. And just checking, minus 2 plus 2 gives 0, which is not what we want, so we can ignore that one. So we want to select these two values, and just like we did above, we use them to form our factors. So we're going to have x minus 1 this time, and x plus 4. And you can see the signs there, the minus and the positive, the plus, coming here from exactly how we set up those factors. So the key difference there was making sure that we choose correctly which of the factors is the negative value, and it must be the smaller in order to get a positive value when you add them together. In this next example that we're going to factorize, you can see that now both b and c are negative values, minus 4 and minus 12. We still start off everything the same way. We want numbers which multiply to give minus 12 and which add together to give minus 4. Now make sure you pop that minus in there. Now again, ignoring the negative for the moment, 1 and 12 will multiply to give 12, 2 and 6, 3 and 4, and that is all of them. So remember, we're going through systematically to get those factor pairs. Now this time, again, we need one of these numbers to be a negative in order to multiply them together and get a negative result. This time, however, we've got a minus 4 for our b value, so the sum of the two factors must end up a negative. So this time, instead of setting the smaller number to be the negative, we want to set the bigger number to be the negative. So now we can see 1 minus 12 will give us minus 11. That's not what we want. 2 minus 6 gives us minus 4. That is what we want, minus 4. And just checking, 3 minus 4 is minus 1. That's not what we want. So we'll be selecting this factor pair to help us factorize this quadratic. So, as usual, x, and this time it's plus 2, and x minus 6. And again, expand out if you're a bit not confident and you want to check that that's correct. The final example we'll look at is x squared minus 13x plus 36. This time we have a negative b value and a positive c value. So again, same deal, we want numbers which multiply to give 36 and which add up to give minus 13. Again, making sure we have the signs in there. Now this time, to get 36, we would want 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6, I believe, is the last factor pair. Now notice we've got a positive result. Okay, we can get that in two ways. We can get 1 times 36, or we could get minus 1 times minus 36, minus 2 times minus 18, and so on. And it's those negative pairs that we're going to want in this case because we want them to add up to a negative value. So we need all of these to be negatives. So we can pop that in. And then checking our values, minus 1 minus 36, well, that's not going to give us what we want. Neither is minus 2 and minus 18. Neither of those are any good. Minus 3 minus 12, that's getting closer, but it's still not there. Minus 4 minus 9, that is the one we want, I think. And just checking, yeah, that's it. So they're the numbers we want to use to help us factor up our quadratic. And as we jump in, we'll have an x, and it'll be minus 4, and then an x minus 9. And there we go. And again, you can expand them out just to check if you like. So there we have our 4 examples of the 4 kind of things that can happen when you're factoring a monic quadratic. We've got positive, 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 negative, 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 and negative, positive. Always the same method I use, but the thing I need to think about is whether my C value and my B value are negative or positive, and what combinations I need to put together in order to satisfy the multiplies to get C and adds to get B. But there it is. Don't forget to look out for the other video if you're interested in factoring non-monic quadratics. So that's the ones where A is not equal to 1. But that's it for the monic quadratic factorization.